this video we will start next topic, that is encoding. So in this video the topic which we will cover is introduction to encoding, why we need to do encoding, then different techniques to do encoding. There are few techniques which are commonly used, like replacing values, label encoding, then one hot encoding, binary encoding, and backward difference encoding. Last one is sometimes miscellaneous features are there, so we need to treat them differently. Okay, so let's start with introduction. Categorical features can only take on a limited and usually fixed number of possible values. So in our data set, generally we have two types of features. One is continuous and categorical. Okay, so the features which are categorical, those can take limited number of values. Okay, so these features are typically stored as text values, represent various states of observation. Okay, so like these variables can be in the form of values can be in the form of male and female. Product type like electronics is there, apparels is there, food is there. Okay, so the type of feature where categories are only labeled without any order of precedence are called nominal features. If I will say like Rohit, Sheila and Rahul, okay, so these are nominal features, like there is no order, so these are called what? Nominal features. Then second is features which have some order associated with them are called ordinal features. For example, like economic status is there, so low, median or high, so these are what? Ordinal features, because order is associated with them, like size of t-shirt, small, medium, large and XL, so there is an order. Okay, and there are also continuous features, like numerical values are there, so there can be infinite number of numerical values in feature, like 1, 2, 3. Then they may be further subdivided as 1.1, 1.2, 2.4, 2.5, like this we can do. So continuous features can have infinite number of values. Okay, and then continuous variable can be numeric or date time. If date time is there, so those can be considered as continuous also. Okay, problem with categorical data. So what are the problems? Categorical features may have a very large number of labels known as high cardinality. Okay, for example, cities. If like there is one categorical feature which is considering the cities in India, so there will be very large number of values, or like URLs on the internet. So cardinality cardinality matlab means the values will be very high, and where most of the label appeared in relatively small number of instances. For example, if we will see URL, okay, list of URLs, so Google and Facebook etc. will have very high number of values, but if we will see any specific URL, so those URLs will have very low numbers of values. Many machine learning models such as regression or SVM are algebraic. So these like regression models and support vector machine etc. are algebraic in nature. So they need numerical values as a input. They will not take these nominal values, like categorical values. String values they will not take. They will only take numerical values. So to use these models, categories must be transformed into number first before you can apply the learning algorithm on them. Okay. So methods for encoding categorical data. So these are the methods, like replacing values, label encoding, one hot encoding, binary encoding, backward difference encoding and miscellaneous feature. We will cover these one by one. Okay. First of all, we will import NumPy, pandas, and these are some commands to import libraries. Okay, so we will run this. Then we will import our flight dataset, and with the help of pd.read csv, we will import dataset and show the first 5 rows of dataset using .head. So this is our dataset. Here we have year column, month, day, departure time, departure delay, arrival delay, carrier, tail number, flight, origin, destination, arrival time, distance, hour, minute. These are columns. Okay, also known as attributes also. Now we will see information like how many rows are there and how many missing values and data types. Okay, so this is all the information. So you can see that this data set contains 16205 rows. Okay, and how many columns are there? Total 16 columns are there, out of which if you will count, 12 columns are numeric and 4 columns are of object type. Okay, so 4 columns, 1, 2, 3 and 4 are object and rest are numeric only. Here you can see 4 are object and float and int are 12. 7 plus 5, 12. Okay, so as we know, we are dealing with categorical features in encoding, so it's better that we will filter them out. Okay, so how we will do, like, this is our data set df write dot select the types, include, we will include like object. Okay, dot copy, and data frame dot select the types, include object dot copy. And what we will do, we will store in categorical data frame flight and show the first 5 rows. So let's run this. Here we will do like this. Okay, so we have separated our categorical features and store them in categorical data frame flights. Now we will check null values in our data set. So to check null values, dataset dot is na dot sum. Okay, so it will show the null values. So you can see that tail number have 25 null values. Okay, so tail number columns has null values. So what we will do, we will impute null values with the mode value. Okay, so show the count of different values in tail number column. If we want to show the count of different values, so data frame, then tail number dot value count. Okay, so it will show the different values in tail number column. So these are the different values. This tail number have 91 values. Okay, we can see. Now what we will do, we will fill the missing values in tail number column with mode value. So tail number dot fill and a, and with what value you want to fill, like the mode value. So we will copy this. Mode value means maximum occurring value, so this is the mode value. So we will copy this, then dot index, and then first value. Okay, so like this we will do. Now if we will see, then it will be 0. So tail number value, missing values are treated now. Okay, so no null values in the data set. Now what we will do, let's check the frequency distribution of categories within the carrier feature. Okay, show the frequency distribution of categories in carrier column. So to show the frequency distribution, in carrier column, we will use dot value counts. So it will show the frequency distribution. Okay, now you can see the frequency distribution. Okay, so this is the frequency distribution of carrier column. To know the count of distinct values within the feature, what we will do, value count dot count. Okay, so there are 11 distinct values in feature carrier. Plotting the frequency distribution of carriers. Now we are plotting the frequency distribution of carrier. So first of all, what we will do, we will count the different values and store them in carrier count variable. Okay, now what we will do, we will plot it SNS dot set style. Okay, dark grid. Okay, now SNS dot bar plot. For x we will take carrier count dot index, comma carrier count dot values, and alpha equal to 0.9. Okay, so let's run this. Okay, so see, you can see that A has most number of occurrences, then come WN, and HA have least number of occurrences. Okay, so now what we will see, replacing values. If we want to replace values, how we will do? The most basic encoding method is just replacing the categories with the desired number. Okay, this can be achieved with the help of replace function in pandas. We can use replace function. The idea is that liberty to choose whatever number you want to assign to categories according to the business use case. So now what we will do, we will create a dictionary which contains mapping numbers for each category in the carrier column. So first of all, we will map numbers for each category in the carrier column. Dot as type. So I will use this list for creating a dictionary which contains mapping numbers for each category. Okay, so curly braces, then carrier, and here comes one, two, three, four, five, six, seven, 11. Okay, so we have created a dictionary. Let's run this. So this dictionary is created. As you can see, defining a mapping by a hard-coded dictionary is easy when the number of categories is low, like in this case 11. We can achieve the same mapping with the help of dictionary comprehension. Okay, you can see that it takes a lot of time for me. Manually, I am writing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so what we can do, we with the help of dictionary comprehension also we can do this. Okay, this will be useful when the categories count is high and we don't want to type each mapping. Okay, we will store the category name in the list called labels and zip it to the to a sequence of number and iterate over it. Okay, so what we will do, categories name in a list called labels. So same thing, this carrier dot s type dot s type category dot cat dot categories dot to list. Okay, and now create dictionary with comprehension mapping. So carrier k comma sorry v for k k comma v in zip labels comma range 1 comma labels plus 1. Why we do why we have done plus 1? Because see here range is starting from 1. Generally range starts from 0, but we are starting from 1 and it will take one value less than the last value, so length of labels plus 1. Okay, So like this we will do. So let's run this. See, with the help of the dictionary comprehension, we can easily do this. Okay. Note, throughout the encoding topic, we will be making a copy of dataset by the dot copy method to practice each encoding technique to ensure that the original data frame stays intact. Whatever. So we are already doing this, that we don't want to disturb our original data frame. So we are making a copy and storing this in a new data frame. So here categorical data frame flights dot replace. We are making copy and storing in this. Okay. It is simple. I think you have understood. So let's run this. Now we will use replace function on the data frame by passing mapping dictionary as argument, replacing values. So this is the data frame. See. So what this has done, it has replaced values in carrier column. Okay, no issue. This is just a simple warning. We have encoded the categories with the mapping numbers in our data frame. We can also check the data types of the newly encoded columns, which is now converted to integers. So if we want to check the data type, see, data type has changed to int64. Okay, now see label encoding. Another approach is to encode categorical values with a technique called label encoding. It allows us to convert each value in a column to a number. Numerical labels are always between 0 and n categories minus 1. Okay, so if there are 5 categories and it is starting encoding from 0, so it will go 0, 1, 2, 3, 4. Okay, so 5 categories minus 1, 4, because it is starting from 0. So this is known as label encoding. How can we do? We can do this by using cat.codes. Okay, so again we are creating a copy of our original data frame in Python. It's good practice to typecast categorical feature to a category data type, because they make operations on such columns much faster and object d type. Okay, so what is it saying? If there is any column, any feature which is categorical, and sometimes it is mentioned as object D type. So object D type generally take more space and less efficient computationally. So the journal make it journal practice that convert it into category data type. Okay. All same thing. Also, the size of category data type column is much smaller than object data type ones. We can do the typecasting by using .type method on your columns. Convert the carrier and origin columns in category data types. .type category, and like this we can do for origin column also, and we will see the data types, then these will be converted into category. So you can see that carrier column is converted into category and origin is converted into category, and tail number is still in object and destination is still in object data type. We can validate the faster operations of category data type by using the type execution time of same operation done on a data frame, which columns as category data type and object data type by using time library. Okay, so we will import this time library. Now what we want to calculate number of flights for each carrier from each origin places. We can use the .group by and .count methods on our data frame to do so. Okay, so percentage time it dot group by carrier origin dot count. Okay, so we will do for this also use this data frame. Run this. It takes 4.73 milliseconds. Okay, approx. And what is the size? See, size is 506.5 because it is object data type. Now we will do same thing with this. In this data frame, we have converted it into categories called data type. So copy this code, use this data frame now. Run this. It will take less time. 1 second. Okay, so it is taking 4.59, and if you see the size will be less, 287 285.7. Okay, so size of this data type is also less. So just convert data column into category if possible. Okay, we can do level encoding via attributes .cat.codes on our data frame columns. This can only be applied on columns having category data types. Do the level encoding of carrier column. .cat.codes. Okay. After that, alphabetically labeled from 0 to 10. So if we will see dot head, so this carrier column will be labeled C between 0 to 10. So this is the count. Okay. the labels are alphabetically ordered from 0 to 10. Okay, using np.where, we can use np.where command also to do this. Sometimes we might just want to encode a bunch of categories within a feature to some numerical values and encode all the other categories to some other numerical values. Okay, so sometimes we want to do differently, like for some value we want to do something and for other values we want to do some other thing. So we can do this by using numpy.where function. We will encode all the US carrier flights to value 1 and other carriers to value 0. This will create a new column in your data frame with the encodings. Later, if we want to drop the original column, you can do so by using drop function in pandas. So again, we are creating a copy of this categorical data frame flights data frame. If the carrier value contains US, replace it with 1, otherwise replace with value 0. Okay. np dot where this value is US. In this data frame, US code value is US, make it 1, else 0. Okay, so run this code. US code. Oh, sorry. This carrier. Here come carrier. Okay, and now we can run this. Sorry. Okay, so you can see that wherever US is there, it is converted to 1, else all rest are 0 only. So like this we can do. Okay, so we can do value counts for 0 and 1. For this column, you can see 0 is this one and 1 is 601. Okay, the column contains two labels, 0 and 1. Now we can do this by label encoder also. From sklearn dot we will import label encoder. From sklearn dot pre-processing import label encoder. Okay, so we will import this. Now we will make the copy. We will create an object lbmake. Okay, which contains label encoder. Now we will do the encoding of carrier column and store in the carrier code column. We are making new column, that is carrier code. lbmake dot fit transform. Okay, so run this. results in new column in the data frame. Categorical data frame flights sklearn.head. So this is the carrier code. Okay. So like this we will do. Now if we will see the value counts of carrier code column, this is the value count. Okay. The categories are labeled from 0 to 10. Label encoding is pretty much intuitive and straightforward and may give you a good performance from your learning algorithm. But it has disadvantage that the numerical values can misinterpreted by the algorithm. Like US is given value 8. Okay, so it may be considered 8 times more weightage from AS carrier. So this is the disadvantage with this. Okay, so rest encoding techniques we will see in next video. Thank you.